So, let us write the forces in y direction. M, here it is written, this is for equation number 1 in x direction, and this is equation number 2 for y direction. So, in y direction what are the forces? Minus P2 A2 sin theta, since it is acting in a negative y direction, plus Fy, this is acting in positive y direction, minus Mg is the weight of the fluid element enclosed between section 1, 2 and 3, 4. This is the net force acting in the positive y direction is equal to dV system over dt is equal to this thing, because we are applying for control volume, flow is a steady, this term is 0 minus B in plus B out in y direction. So, in y direction we have m V2 sin of theta, m V2 sin of theta, here we have to multiply it by V2, m V2 sin of theta, and this V1 will not have any component in y direction. So, momentum going outside the control volume minus momentum going inside the control volume. Inside the control volume it is not entering in the direction of the y. So, this is 0. So, this is equation number 2. With the help of equation number 2 we can find out Fy, and with the help of equation number 1 we can find out Fx. So, in this manner we can calculate the force on the fluid acting in x direction and y direction. Now, we can find out the force on the bend. So, with the help of the reactions only we can find out the reaction on the bend, which is in negative Fx direction and negative Fy direction. So, with the help of this figure we can find out the magnitude as well as the direction of the forces acting on the bend. Now, after understanding how to write the momentum equation in x direction, y direction, or for any control volume, if we have this problem, in this problem we have a box. This is a box fitted with pipe in 4 directions, 1, 2, 3, 4. Through these 4 pipes fluid is coming in, going out, right. In this question we are asked to find out the force in x direction and y direction need to be applied on this container to keep it in static equilibrium condition, right. So, how can you write equation for this problem? Now, in this case first we have to assume control volume. So, this is selected here, this control volume, we select control volume, and on this control volume apply all the forces on the fluid. This is Fx and this is Fy due to the surface on the fluid. Now, with the help of this interaction of the fluid of this control volume to the outside fluid, we can write Fx and Fy. We can write equation in x direction and y direction, and with the help of that we can calculate Fx and Fy, right. So, in this problem Q1 is given, Q2 is not given, Q3 is given and Q4 is given. Since flow is a steady flow, here it is written, assume no mass to be accumulated inside the black box and all pressures are 0 gauge, means everywhere pressure is atmospheric pressure, right. So, with the help of continuity equation we can say that whatever flow rate is going inside, that must be going outside. So, we will get one equation, through that equation we can find out Q2, right. So, with the help of continuity equation we can find out Q2, right. So, after knowing Q2 we can write equation or momentum equation in x direction. If we want to write momentum equation in x direction, then how do we write? So, momentum equation in Fx direction, first we have to find out the forces on this control volume in x direction. What is the force acting on this control volume in x direction? It is equal to Fx only, because as such pressure everywhere is assumed to be atmospheric. So, no pressure force is being applied on this control volume. So, what is the force acting on this control volume in x direction is equal to Fx. Now, this Fx is equal to, flow is a steady flow. So, it will be equal to dV system over dV control volume divided by dt, that term will be 0. d according to Reynolds transport theorem, this is dV over dt minus B in plus B out is equal to rate of change of system, right. So, with the help of Reynolds transport theorem, that rate of change of property of the system is equal to these three. So, first term will be 0 because flow is a steady flow, minus B in means momentum going inside the control volume in x direction. This is x direction and this one is y direction.